Today's lesson is the quadratic formula and the discriminant. This is lesson 9.6 in your textbook. Okay, so first I want to do a refresher. How many solutions can a quadratic have? So think about the parabolas and where they hit the graph. When we're talking about solutions, we're talking about x-intercepts. So if you think about x-intercepts, we can have two x-intercepts where the graph hits the x-axis twice and it has two solutions. We could have where it hits one time, that has one solution, or we can have a parabola that doesn't hit the x-axis at all and that has no solutions. Okay, this is going to be important when it comes to using the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that's a very long formula. And when you're thinking about it, you want to think of this part here as not necessarily being negative, but as the opposite. So I always say the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And when you're doing this, you have a and c are being multiplied together. Where do we get a, b, and c? Well, we get that from our equation. So if you remember, this is standard form of a quadratic. So the a is always the number in front of x squared, b is always the number in front of x, and c is always the constant. And then we just set that equal to 0. So a quick and easy way to remember the quadratic formula, I have two songs for you. These are also uploaded on Schoology, so if you need to access them later, you can. So I'm going to go ahead and play both of them, and you can figure out which one works best for you. Now, fair warning, these do get stuck in your head. The first one is actually the song that I learned when I was in school to remember the quadratic formula. So let's go.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, very short and easy. It's like the song Pop Goes the Weasel. And then this is a little bit more modern one that I've found since then a lot of students like.
Get out, get out, get out of my head. Fall into my arms instead. I don't know what it is, but I need that one thing. You got that one thing. Good. So if we use that same chorus, we can sing the quadratic formula right here behind me. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you know the quadratic formula. Now you know the quadratic formula. So that's how it goes. Let's do it one more.
All right, so I'm going to skip the rest of it because it goes on and has the whole entire class sing it. All right, so when we're talking about these ones here, the very first thing we need to do, this is example number 2 in your textbook, we have to get everything to one side because we want it to be in standard form and we want it to be set equal to 0. So if you look at example number 2, we have this 4x over here. We need to get it to the other side. So to do that, we need to subtract 4x from both sides. Whoops, sorry about that. Subtract 4x. Okay, so now this goes away and we have equals 0. Now when we're looking at the left-hand side, can I take 4x away from an x squared? No, they're not like terms. Can I take a negative 4x from negative 7? No, again, they're not like terms. So I can't subtract negative 4x from either one of these. So I'm going to put them side by side. And I always try to put them in order from the highest degree to the lowest degree. So remember, the degree is our exponent. So in this case, x squared would go first, then negative 4x, and then -7. Your constant is always at the end. Okay, and now this is in standard form. So now that we have it looking like this, we can use the quadratic formula to figure out how many solutions this quadratic has. Okay, so now that I have it in the right format, we need to determine what is A, what is B, and what is C. So I'm going to make a list here. All right, so remember, A is always the number in front of my x squared. Well, technically, there's an imaginary 1 there, so A is equal to 1. Okay. B is the number that's in front of my x, so that is -4. And C is my constant, which would be -7. So now that I have my list going here, I can plug these numbers in to the quadratic formula. And it's just substitution. So here's my hint for you. When you plug them in, put them in parentheses. It makes it a lot easier, especially when you have negatives and the squared. Your calculator will sometimes lie to you and give you the wrong answer because it doesn't understand the order of operations. So I'm going to go through. We have the opposite of B. B is -4. Plus or minus the square root. B again is -4 minus 4. A is 1. C is -7. All over 2 times 1. So see how all these sets of parentheses are each one of those letters. Let me see if I can change colors here, because I'm going to show you how to simplify this a little bit. So I always do this, I call it 4 chunks. So the first chunk I'm going to do is this piece right here. What is the opposite of -4? The opposite of -4 is +4. Plus or minus the square root. Okay, the next chunk that I do is this part right here, -4 squared. So remember, that means -4 times -4. A negative times a negative is a positive. So 4 times 4 is 16. All right, the next chunk, I do all of this at one time, including that minus sign. Okay, that minus is going to become -4. So -4 times 1 is -4. -4 times -7 is +28. Okay, so make sure you always treat that minus sign as a negative. Okay, and we're going to put that over our last chunk. 2 times 1 is 2. Okay, so this part that's in purple is a lot simpler than our original, but we can make it a little bit more simple. Okay, so the next step, I'm going to change colors here, is we're going to simplify a little bit more. I think that we can simplify the part that's underneath the radical. So I have 4 plus or minus the square root. 16 plus 28 is 44 over 2. Okay, so it's getting a lot easier. Now, the square root of 44 is not a perfect square, so I know that my answers are going to have a decimal. So I can simplify the square root of 44. So what I'm going to do is I'm going to go up here, and if you do the square root of 44 in your calculator, let me grab my calculator real quick. We get 6.63, and there's a whole bunch of other things, but we can say 6.33. Or sorry, 6.63. So I can say 4 plus or minus 6.63 over 2. Now, we get to the point where we have the plus and the minus. That means that we have to do both. So I'm going to split this into 2 separate equations. The first one is going to be 4 plus 6.63 divided by 2. And then I'm going to do 4 minus 6.63 divided by 2. Okay, and I should come up with 2 answers for this. All right, so 4 plus 6.63 divided by 2, well, that gives me 5.32. So that's one of my solutions. And 4 minus 6.63 divided by 2 gives me negative 1.32. So those are my two solutions to this quadratic. Okay, so let's try this one. There are two triads. There is triad A and triad B. So what I recommend at this point in the video, pause, try this one on your own, and when you're ready to restart, hit play, and then we can go over the answers, and then I'll show you part B. So I'm going to pause here for a second in case you want to pause your video, and then I'll go over the answers. Okay, so just like the one that we had before, we need to get everything to one side. So in this example, we need to move everything to one side. Okay, so I need to get this x squared over to this side here. So I would subtract x squared from both sides. Okay, so my x squared over here is now gone. So I have equals 0. And I can't take x squared away from a constant or from something that doesn't have the same exponent. So I'm just going to put them in order from the highest degree to the lowest. So we'd have negative x squared minus 4x. And then 21 is positive. So let's go ahead and make that a positive 21. And this is the equation that we're going to use. Okay, so now in looking at this equation, I have to determine what is A, B, and C. So in this case, A equals negative 1 because there's a negative sign in front of x squared. B equals negative 4. And C equals 21. All right, so let's go ahead and substitute these three values into our quadratic formula. So we have the opposite of our B value, which is negative 4, plus or minus the square root. B is, again, negative 4 squared minus 4. A is negative 1. C is 21 over 2, and then A is negative 1. So notice how every single value that I substituted in, I put in parentheses. Okay, so now comes the time to do this in separate pieces. So I'm going to do the same thing I did before. I'm going to circle the pieces as we do them. So the first piece we're going to do is this negative 4. So the opposite of negative 4. Well, the opposite of negative 4 is positive 4. Okay. Plus or minus the square root. Okay, the next piece we're going to do is this piece right here. So negative 4 squared. We had that in the last problem. Negative 4 times negative 4 is positive 16. So 16. All right, the next part, we're going to do all of this in one piece. So negative 4 times negative 1 times 21. Okay, so if you do negative 4 times negative 1, you get positive 4. Positive 4 times 21 is 84. Positive 84. Sorry, I forgot to change colors there. Let's see if I can type over top of it or write over top of it. There we go. Over. And then our last piece is our denominator. 2 times negative 1. 2 times negative 1 is negative 2. Okay, so let's see if we can make this a little bit simpler. Let's simplify what's underneath the radical. So right now we have 4 plus or minus the square root. 16 plus 84 is 100 over negative 2. I can simplify even further because 100 is a perfect square. So you can think to yourself, what times itself gives you 100? In this case, it's 10. So I have 4 plus or minus 10 over negative 2. When I get to the point where I have 3 numbers like this, I know I'm going to have 2 whole number answers, whether it's positive or negative. And this is my almost last step. So this is where you're going to split it into 2. Okay, the first equation we're going to do is 4 plus 10 divided by negative 2. And then we're going to do 4 minus 10 divided by negative 2. So that plus and minus, we have to do one that's addition and one that's subtraction. Okay? Well, the first one, 4 plus 10 is 14. Divided by negative 2 gives me negative 7. So that's one of my answers. All right, 4 minus 10 is negative 6 divided by negative 2. Well, negative divided by negative is a positive, so 3 is my other solution. So those are my 2 solutions to this quadratic. Okay, if you want to double check and see if you got this correct, you could take either one of those numbers and plug them in for x in the original, or you could graph this on Desmos and see where your x-intercepts are. They should touch it at negative 7 and 3. Okay, here's try it number 2, or part B. So I'm going to go ahead and pause for a second. If you want to pause the video, try this one on your own, and then review the answers. Okay, so just like the other ones before, we have to get everything to one side. So we want to move this 24 over this side. So I would subtract 24 because it's positive. Okay, and we have equals 0. X squared and 2x cannot be combined, and I can't take 24 from either one of those because they're not like terms. So again, I'm going to write them in order from least to great, or sorry, greatest to least degree. So we have x squared minus 2x minus 24. Okay, remember that order is important because that determines what is A, what is B, and what is C. So in this case, A is equal to 1, B equals negative 2, and C equals negative 24. Okay, so let's go ahead and substitute these values right here into our quadratic formula. Okay, so the opposite of our B value, which is negative 2, plus or minus the square root. B again is negative 2 squared minus 4. A is 1. And our C is negative 24. All over 2 times our A value, which is 1. Okay, so I have 5 sets of parentheses because I have 5 letters in my equation. Okay, so let's go through and see if we can simplify. Whoops, I'm going to go back. All right. So, first piece, negative, negative 2. The opposite of negative 2 is positive 2. Plus or minus the square root. Okay, negative 2 squared. So negative 2 times negative 2 is positive 4. And then this piece right here, so we have negative 4 times 1 times negative 4. Sorry, negative 24. So negative 4 times 1 is negative 4. Negative 4 times negative 24 gives me positive 96. And lastly, 2 times 1 gives me 2. All right, so looking at this, is there anything that we can simplify? We can simplify what's underneath the radical. So we're going to say 2 plus or minus the square root. 4 plus 96 is really 100 over 2. All right, so it's not always going to be 100, but in these 2 examples, they were. We already talked about the square root of 100 is 10. So we can say 2 plus or minus 10 divided by 2. So now that I have 3 numbers, I can separate this into 2 equations. I'm going to do the positive one first. 2 plus 10 divided by 2, and 2 minus 10 divided by 2. Okay, so 2 plus 10 is 12. Divided by 2 gives me 6. That's my first answer. 2 minus 10 is negative 8. Divided by 2, that gives me negative 4 as my second answer. So those are my two solutions to this quadratic. Okay, again, if you want to double check, substitute 6 into the equation, substitute negative 4 into the equation, and you should balance it out. They should equal 24. And another option is to take this into Desmos or graphing calculator and look at the x-intercepts. Okay, example 3 is a real-life application problem. So in this case, we have the height of a frog after X number of seconds as it jumps off a rock. So what is asking us is how many seconds is the frog in the air before it lands on the ground? So we're trying to figure out time-wise how long it took the frog to jump from 0 to where it landed. So that's what we're trying to find. We're trying to find the time in seconds. So they give us the equation. So we're going to use the equation to plug into our quadratic formula. So in this case, A equals negative 16, B equals 10, and C equals 0.075. Okay, so don't be scared. These ones could give us some big numbers, and it's okay. So we are just going to substitute everything we know. So we have the opposite of B, which is 10, plus or minus square root of B squared minus 4AC all over 2A. Okay, so let's see what we can simplify. So the opposite of 10 is negative 10 plus or minus the square root. 10 squared is 100. Now here's the part where I need to plug this into my calculator. I have negative 4 times negative 16 times 0.75. And I get 48, positive 48. All right, if it was a negative, I would put a subtraction sign there, but this one was positive. I want to make sure that I know that my first number is negative. And then 2 times negative 16 is negative 32. Okay, so let's simplify the radical. So we have negative 10 plus or minus the square root. 100 plus 48 is 148 over negative 32. Okay. So the square root of 148 is not a perfect square. So we can simplify that one. So if I go ahead and put in my calculator, I get 12.165. So I'm going to round that to 12.17. So I have negative 10 plus or minus 12.17 over negative 32. I apologize. My dog is here and is drinking really loud. So we're just going to keep on going. All right, so now I have my 3 numbers. Now I can simplify and use the plus and the minus. So if I do negative 10 plus 12.17 divided by negative 32, and then I'm going to do the negative one here in a second. So let's try it out. So negative 10 plus 12.17 divided by negative 32, that gives me negative 0.0, we'll say 0.07. Oops. All right, now I'm going to do the positive one. Oh, sorry, negative one, because we already did the plus. Now we do the minus. So negative 10 minus 12.17 over negative 32. So I'm going to do the same thing in my calculator. Negative 10 minus 12.17 divided by negative 32, and I get 0.69. Okay, so same process that we did before. Now here is the only difference with these real life application problems. Okay, so we're talking about time. When it comes to time, does it make sense to have negative number? Can you have negative time? So when that frog jumps from the rock until he hits the ground, this spot right here, could that be negative? In this case, no. So we have to get rid of that answer there. That does not make sense that it would take negative 0.07 seconds. So our only solution is this. This only has one solution in this case, and that is it would take 0.69 seconds, or that much of a second, to land on the ground. Okay, so when it comes to application problems like this, the word problems, think to yourself, does negative numbers make sense in that problem? Okay. All right, so let's try it. So if you want to, pause this video, try this one on your own before we review the answers. Okay, so same thing as before. Looking at our equation, we have to identify A, B, and C. So A is negative 16. B is 10. And C is 0.3. Okay. So we need to substitute these into the equation. So we have the opposite of B, which is 10, plus or minus the square root of 10 squared minus 4. That minus 4 is always in the equation. A is negative 16, and C is 0.3. All over 2 times our A value, which is negative 16. Okay, so let's go through. The opposite of 10 is negative 10, plus or minus the square root. 10 squared is 100. Negative 4 times negative 16 times 0.03. Well, that gives me 19.2, positive 19.2. And then 2 times negative 16 is negative 32. Okay, cleaning this up a little bit, underneath the radical, if I add 119.2, I get 119.2. So I have negative 10 plus or minus the square root of 119.2 over negative 32. Now, some of you might be able to jump right from there, the first step to this step here. That's fine. I write out all the steps to make sure I don't miss anything. Okay, so now if I had to do the square root of 119.2, okay, I put that in my calculator, I get 10.9 roughly. I rounded that a little bit. So I have negative 10 plus or minus 10.9 divided by negative 32. So again, once I get to the point where I have 3 numbers, this is where you're going to split it into 2 separate equations. So negative 10 plus 10.9 divided by negative 32, and negative 10 minus 10.9 divided by negative 32. The only difference between these two is one has a positive on top, or an addition problem, and the other one has a subtraction problem. Okay, so the first one, negative 10 plus 10.9 divided by negative 32, I get negative 0.028. Again, I rounded a little bit. Okay, and my second one, I get 0.65. Okay, so looking at our problem, we have to figure out what are we talking about and which one makes sense. So in this one, they're talking about, again, the height of a frog over time, how many seconds in the air before he lands on the ground. So does it make sense that it took the frog negative 0.028 of a second to hit the ground? Okay, he's not going backwards in time, so that -1 is not an option. Does it make sense that he took 0.65 of a second to hit the ground? Yes. So this one has, again, one solution. Okay. So the next part that we need to talk about is the discriminant. The discriminant is the part that's underneath your radical sign. So this piece right here. So b squared minus 4ac. Now, the reason why we use this is the discriminant is used to determine how many solutions a Quadratic has. So without me having to do the entire quadratic formula or without having to graph it, I can look at just that one piece and that will tell me if it has one solution, two solutions, or no solutions. Remember, roots and solutions are the same thing. They're just used interchangeably. So the discriminant. If the discriminant is greater than 0, then you have two real solutions. If the discriminant is equal to 0, then you have one real solution. But if the discriminant is less than 0, then you have no real solutions. Okay, and what they mean by real solutions, they mean real numbers. Okay, when you get to Algebra 2, you will talk about numbers that are not real. Okay, but these are the three we talked about: one solution, two solutions, or no solutions. So let's go ahead and use the discriminant. So in example number 4, they want us to determine the number of solutions. So just like we use the quadratic formula, we have to first determine what is A, B, and C. So in this case, A equals 1, B equals -4, and C equals 3. For this one, I did not have to do any solving first. It was already set up for me in standard form. So that's how I was able to determine A, B, and C. Okay, so remember, we only want the part that's underneath the radical, the b squared minus 4ac. So b is -4, and I'm going to use parentheses just like I did in the quadratic formula. So b squared minus 4 times a times c. Now this is going to be a lot quicker to solve. So -4 squared is 16. And then -4 times 1 is -4. -4 times 3 is -12. So 16 minus 12 is 4. Okay. So if we look at this, 4 in our table, 4 is greater than 0. So this one has two real roots. Or you can say two solutions. Okay, and this one, same thing. It's already in standard form. A equals -1, B equals 4, and C equals -4. Okay, so if I substitute everything into b squared minus 4ac, I have 4 squared minus 4 times -1 times -4. Okay, 4 squared is 16. -4 times -1 is +4. +4 times -4 is -16. Oops, sorry. 16 minus 16 is 0, so it has one root or one solution. Okay, in example 4c, a equals 1, b equals -4, and c equals 5. Okay, again, I substitute in, same thing. So b squared would be -4 squared minus 4 times 1 times 5. -4 squared is 16. -4 times 1 times 5, that gives me -20. So my discriminant is -4. And -4 is less than 0, so we have no solutions for this one. So this would be one where if you have the axis, it would not touch at all. So it does not have any x-intercepts. Okay, so here are your two trials. So go ahead and pause if you need to. Try these two, and then come back for the answer. Okay, in part A equals 1, B equals -10, and C equals 25. So when we substitute those in, we get -10 squared minus 4 times 1 times 25. Okay, negative 10 squared is negative 10 times negative 10, which is 100. And then negative 4 times 1 times 25 is negative 100. So our discriminant is 0. So this one has no solutions. Okay, and the second one, A equals negative 1. B equals negative 6. And C equals negative 10. So all negatives. So we have negative 6 squared minus 4 times negative 1 times negative 10. Okay, so negative 6 squared is positive 36. Okay, this is where I was telling you your calculator will lie to you. If you don't put those parentheses in there, it will tell you that negative 6 squared is negative 36 because it'll take 6 squared first and then apply the negative, which is the incorrect answer. So make sure when you're putting these in the calculator that you use parentheses. All right, negative 4 times negative 1 is positive 4 times negative 10 gives me negative 40. So 36 minus 40 gives me negative 4. Negative 4 is less than 0, so this one has no solutions or no roots. Whoops, sorry. And up here, nobody caught me. I didn't catch myself. Sorry. For the first one, it was equal to 0, so this one actually had 1 root or 1 solution. I apologize. Okay, so we had part A has 1 solution and part B has no solutions. All right, so this is the classwork that's assigned for this lesson. So you're going to go to page 393 and 394, complete numbers 6 through 13. Those ones are really quick. And then 19, 21, 23, 29, 31, and 33. So we gave you a couple from each type of skill. If you need to, go back and look at the section. The textbook pages are on Schoology, or you can rewind this video and watch there. The exit ticket is number 20 and number 30. I believe they are on page 394. You need to turn those ones into me for feedback. So you can turn them into me by email, by your Google Drive, or on Schoology. Okay, these pages can be done on a piece of paper, and you can just take a picture of them, you can scan them, or you can put them into a Word document. Whatever works for you. If you would like me to check your classwork, send it my way, and I will check it and get back to you. But the exit ticket, this is the one that I will be collecting for feedback. It is available in Schoology. Just find the folder for this lesson, and then you can submit it to me, and I'll get your response right away. All right, thanks for watching.